coming to some more queries. Again, these two are multiple choice questionnaires. We'll quickly discuss them. Question number 11 from 3.3. It is given A and B are symmetric matrices. We know if A and B are symmetric, that means we can write A transpose is equal to A and B transpose can be written as B. So this is the given condition. Under this condition, you tell what is AB minus BA. So if I have to know what is the nature of this matrix, we will find its transpose. So we can evaluate AB minus BA transpose, which using the properties of transpose of matrix, we can write it as AB transpose minus BA transpose. Further, this one is B transpose, A transpose minus this becomes A transpose, B transpose. Also, we know A transpose is A and B transpose is B. So, it is finally reducing to BA minus AB. So, you need to only check, are these two identical? You will find they are not same. But if I take minus common, we get AB minus BA. So, we find the transpose of given matrix is negative of itself. That means we can say AB minus BA is skew symmetric. You will see, you check which option is this. It is option A. So option A is the correct answer for this one. Okay. Then the next one, we are given matrix A and also the sum of matrix A with its transpose is the identity matrix. So I have written transpose of A here. Now we are going to use this equation. Now A plus A transpose is identity matrix. Okay. Adding the matrices on the left hand side, cos alpha plus cos alpha will be twice of cos alpha. This is minus sin alpha plus sin alpha. So it reduces to 0. In the same manner, sum of these two will be 0 and cos alpha plus cos alpha will be twice of cos alpha. On the right side, we have got identity matrix. Because these two matrices are equal, so their corresponding elements have to be equal. Let us equate the corresponding elements. Any one you can equate. We can say 2 cos alpha is 1 or we can say cos alpha is 1 by 2. So what should be the angle alpha? Cos is 1 by 2 at pi by 3. So if you look at the options, you will find one of the option as alpha is pi by 3. So that will be the correct solution. Okay. Now coming to 13.4, which is about elementary row transformation. We did some examples from there where we were able to find the inverse of all the matrices. This is different from those matrices. It is possible that some square matrix is not even having any inverse. So this is of that type. Now matrix A is of order 2. The elements I have written here. I will be using elementary row transformation in order to get the inverse of this if it exists. So using the equation A is equal to I times A and then substituting matrix A and I here. You know the rule very well. This is to be converted to identity matrix. You will take elementary row transformation in such a way that this becomes an identity matrix. Try to change the elements column wise. Let us see whether it is possible or not. So think of an operation using which 6, the first element, can be reduced to 1. As I told you, we will be changing them column wise. So we want to convert 6 into 1. So 6 can be converted into 1 if I divide the first row by 6. So if I write R1 as 1 by 6 times R1, then the matrix on the left hand side reduces to, this becomes 6 by 6, this will become minus 3 by 6, which is minus 1 by 2. Second row will be as it is. On the right hand side, applying the same operation, this is what we get. Fine. So this is converted into a required number. Now after this, this is to be converted to 0. So let us convert it to 0. In this minus 2, if I add 2 times 1, so I can write R2 as R2 plus 2 times R1. That will make it 0. So this time we are using the operation on second row. So first row I will write as it is. So R2 is minus 2 for the first element plus 2 times 1 we are going to do. So you can see it is minus 2 plus 2. So it will become 0. Now moving on to the second element of the row. The element is 1. To this we are adding 2 times minus 1 by 2. So you see 2 and 2 gets cancelled out. We have 1 minus 1 which is 0 only. On the right side, first row as it is, second row we have to change. So it is 0 plus 2 times 1 by 6. This will reduce to 1 by 3. This will be 1 plus 2 times 0 which is 1 only. Now the problem arises. Look at the elements of second row. They have come, both have reduced to 0. And how will I convert this to 0 now? In order to convert it into 0, this number should not have been 0. Then only this can be converted to 0. Because that is the next thing we have to do. But we cannot design or frame any row operation using which this can be now made 0. So beyond this we are not able to proceed. The reason being, while converting this to 0, this element also got converted to 0. So what we see here, inverse does not exist. Now when we have started with the concept of matrices, you will come to know what type of that square matrix should be so that its inverse does not exist.